Michelle, you might want to introduce Team Brookvale.
Yeah.
Yeah.
So today we've got the two guys from Team Brookvale, Ed and Thomas. Hey guys, you're on the line. So these guys started, as you can see by their really fancy headphones, started as a mobile game dev company, but shifted into automation software and IoT projects. So I'd caught up with them a few times when we were on the Gold Coast and thought they had some really cool projects to share with you guys. Lots of wins and then a lot of learnings as well that you could probably share. And they've been working with a wide range of clients. So it says there were ASX 200, S&P 500 companies all across the world. So yeah, without further ado, I'll hand it over to you guys for the next couple of minutes to talk about yourselves and what you want to talk about today. So see if you can get your screen up. There we go. Cool. And then we'll jump back in about 20 minutes, 30 minutes whenever you're done.
And feel free to ask questions in the chat or in the Q&A question panel up the top if you're participating in the audience as well. Just a last tip. So thanks, Ed and Thomas.
Thank you.
Yeah, no problems. So let me just set it up. So can you guys, oh, yes, okay. So it's shared correctly. Okay, cool. So introduction of Team Brookvale. So we're a software development company, and today I'm going to talk about two projects, two case studies, and focus on IoT and talk about our learnings. So first one's going to be a smart lock IoT device development, where timing is perfect because it just got released. It's available in Bunnings, and it's been quite a long project. This is for one of the biggest, if not the biggest, lock manufacturer in Australia. The other one is a Cryo Sauna automation. It's a completely different area, but it's still it's focused on IoT and automation. So it's going to be an interesting one. A bit of background. So I'm an electrical engineer, focused on energy management systems and embedded systems during uni, and tried consulting as well. So worked for Deloitte, Reserve Bank of Australia, which is very different, but then went back to software development 7 years ago and started out with games, mobile games, which was fun, and we had reasonable success. One game got featured in a Time magazine, but we quickly realized that we want to develop software for other companies if we want to make a living out of this. So first case study is the IoT lock. So basically, the smart lock is a lock that you can operate with your phone. If you're in the proximity of the lock, you use BLE. If you're remotely, then you use the cloud plus the gateway. It has some cool features that you walk up to your lock and it opens the lock without, or unlocks the lock without you take the phone out of your pocket. So it's completely passive while the phone is in sleep mode. That was quite a hard feature to do properly, but we're gonna cover that later. It does over-the-air updates of the firmware on the lock and does a few more stuff too. So this is what it looks like. We just took the photo this weekend in the local Bunnings, so it's really good to see that it's available. You can buy that, and let's talk about the BLE part of it. So BLE, developing against BLE is not necessarily easy. It's easy on a proof of concept level, but it's quite hard once you want to get something working on a production grade product, and especially on Android. So iOS is okay, but on Android it gets actually quite hard because things you take for granted on iOS just doesn't exist on Android. For example, you want to send 10,000 packets to your BLE device because you're doing an over-the-air firmware update. On iOS, you just send 10,000 write commands in the right order, and iOS puts them into the right order and just handles the threading, everything. Whereas on Android, you have to make sure that you get the call back first of that the right packet was successful, and then continue with the next one. There's way too more things that you want to you have to take care of. Also, disconnecting from a device. On iOS, you just cancel peripheral connection, and that's it. On Android, you got the disconnect, you got the close, you're missing one of them, and it still works for a while, but then you may run out of the number of connected devices limits, or just not connecting again. These are the stuff that's not easy to debug. And also extracting away low-level BLE operations is important, was important in this case. So we just came up with a device pushdown automaton, which is basically a state machine which has a dozen states on the top of each other and only goes to the next one once the previous one was successful. So few of these states: first, scan for the device; second, discover characteristics; before that, discover services; connect to the device even before that; and then write the status query, then read the status query. So all of these were just states that you go through, and all of these can fail and do fail, and you have to want to handle them properly. Also, a bit of about the architecture of the app. We used Redux worked really well for us in the web world for automation projects and web application, and we were using that on mobile apps too, and it's just working really great. So the main, probably quite a few of you have heard of Redux because it's been really popular for the last 4 or 5 years. What it does really is on the UI is not listening to the, and not just the UI, pretty much everything in the app is not listening to the events, but listening to state updates. And that's the power of that. So when you say you got the user list and you add the new user, then you got an action, which is in the top right corner, that new user action got fired. And then it hits the store, and the reducer checks what to do with this, that there's a new user event, then adds the new user into the state, and then the actual coordinator, which is basically the screen, what the user can see, is checks if there were any changes within the users if you're on the user screen, and if so, it's going to show the new user on the screen, but not because there was an event of a new user event. It's because the state changed and the new user just came up. And that just solves lots of issues, especially race conditions, and just it's much easier to reason about your code and what it does. The keyless entry, that was one of the biggest challenges, the passive keyless entry, where you're walking up to your lock and it opens the door. That was one of the biggest issue, because it's hard to debug. When the phone is in your pocket and you're leaving a geofence and then entering a geofence and you walk up to your lock, you just can't do this with a computer attached to your phone, or even if you do, the phone acts in a different way if it is connected. So pretty much the only way to properly debug this feature is just firing local push notification and walking far away, even 500 meters away from where your lock is. And obviously you can have tricks to trigger certain events like geofence left and stuff like that, but it won't be the same. So this is one of the hardest stuff to do. This is not well documented, but the lock has to open before you reach the lock. You walk up to your lock, and that was one of the biggest challenges, but we solved that. Over-the-air update was pretty much a smooth sailing on iOS. Just send all the packets, and once, if anything fails, just restart later. Just start the whole process again. But on Android, that was quite a bit of a challenge again, because on Android you have to look after a lot of things. So what we did, actually, we wired it up with Redux. So once the fragment hit the lock, make sure that we got the response that it's fine, and then start with a new fragment. And wiring this up with Redux actually just solved all the issues that we had before. Also, the other one is a perfect MTU size. So the packet size, it's important, because if it's too small, it's going to take forever to upgrade your firmware. If it's too big, it's not going to be successful. So that's something also that way we had to do some negotiations and things like that, especially that Android devices are so different. The second one I'm going to talk about is the Cryo Sauna. It's basically you walk into a chamber and it's minus 170 degrees. You've been frozen down for 2 minutes. If you stay longer, you actually do freeze. So it's not, you can't do that, and it's not wise to stay longer than that. And apparently it's good for skin rejuvenation, it's good for your muscles, it's good for a lot of things. But actually just ask a doctor, because yeah, we're not sure and never tried it, despite we developed the automation for this specific cryo sauna. So the challenges here is there's one gas bottle of nitrogen, and you don't want to run out of that, because if you do, then your client's going to come who paid a fortune to go into your chamber, and you just can't freeze them. And that's why it's very crucial that each and every client come at exactly the same time, and there's no downtime between, or virtually zero downtime between the client. So that's where we had to come up with a few solutions. And first one was the new bookings opening dynamically once a bunch of bookings are filled up. So let's say that for Thursday, we only got bookings open between 12 p.m. and 1 p.m. And once all the slots fill up, our system is monitoring the booking system through the API. Just open up a 15-minute slot before and after. And once that fills up again, a 15-minute slot before and after gets open up. So that way, all the clients are coming in just one bulk. And the other one is streamlining the process of the clients coming in and out as quickly as possible. So what we do is, in this image, you see 3 change rooms. Actually, there's 4 there. And there's a left side of that where there's a treatment side. And also there's a door on the other side of the change rooms that you can't see in the picture. That's where the clients are entering to the change room from. So there's a sensor on these doors. They're entering the change room. The change room iPad gets triggered. It shows the video what's going to happen to you. You sign the waiver on the iPad and even touch a button that you're ready. And then in the treatment room, the operator sees who's being ready, and whoever's ready just pushes a button on the iPad. That change room opens after the previous change rooms got closed, so people don't see each other undressed. And then the person walks into the cryo chamber. It takes two minutes for the treatment. Then walks back to his change room, and then the operator pushes another button for another change room. So the previous client's door closes, the other one opens, and there's virtually no downtime between the clients. So we got the client version and the storage manager version, obviously, of the app. It's actually just one app, but you get a secret menu that you have to trigger. And it's interesting for the sensors and the actuators for the doors. The client didn't want to have a industry grade Ethernet controlled IO device like a Moxa one. He wanted to go cheap devices, but with redundancy. So we use Raspberry Pi with a Pi-phase board. And together with the case, it cost $100, or it did cost $100 a couple of years ago. And it's so cheap that he could have some extra raspberries in the salon in case one of them fails. But actually, none of them fail. So it's proven to be a very reliable system. The automation results, the outcome is, in the last couple of years, they never run out of gas, which is an important factor, because it's a huge reputational risk if the client shows up and can't have his treatment. The other one is one person can operate the whole cryo sauna salon, just because everything is automated, so not much that the operator has to do. And also the equipment usage and the staff's opening hours can be optimized by making sure that everybody comes in one bulk. So just on staff costs, you're saving tens of thousands of dollars, and on gas usage, you save a huge amount. And that were the 2 case studies that we thought were quite interesting and IoT related. And just wondering if you got any questions. Yeah, I got a few. So what sort of device testing did you have to do to take it to production? So which project is this? I'm guessing for the Lock one. So for the iOS is in production. It's basically testing on iOS many people. So it was all manual testing. We didn't do any automated testing for the actual user interface. It's all manual testing, but manual testing by a around 50 people for weeks. What Redux middleware did you use for side effects like core Bluetooth? Yeah, that's an interesting one. Okay, so the Bluetooth didn't go through the Redux except for a few exceptions. So for the BLE, for core Bluetooth, we use the push down automaton, where it's event driven. So that's actually not state driven. So we got an event like that. We got a response from the BLE device. That's an event, and that event triggers the device push down automaton. So that doesn't go through the Redux. So what goes through the Redux and BLE related was the OTA for Android to making sure the packets are in order, and also the UI related stuff of BLE. Do we have plans to use ultra wideband instead of BLE in the future? Well, it's not our call, so we acted upon procedures. So in this case, what the client wanted, this lock company, was BLE. We could have many ideas. So Zigbee was one of the options that we were going to implement, HomeKit. So yeah, we got a couple of ideas, but it's not our call what to use. But yeah, if we had a choice, yeah, we would. Why not? Thank you. Any other questions? Okay, I think I just hand it back to you guys.
Thank you so much, Ed and Thomas. That was awesome. Really great hearing some of your work across those two use cases. And thanks for coming and presenting and sharing that with us. I know I'd never heard of a Cryo Sauna before, let alone that you needed to IoT plan it. So
yeah, I thought the first example was really good because it's like, oh yeah, I get that, a lock, I can see that working. We can go and like see one in Bunnings, and your examples were really specific, like the things, the pain points that came across that I'm sure like lots of people would come across. And the last one was just interesting. It was really cool. Like you said, never heard of a Cryo Sauna before, but
it just goes to show that you can really use IoT on anything you can think of these days, which is like it's a testament to the industry and how much it's grown in the last 10 years, I think. So thank you so much for joining us, guys.
Thank you.
Thank you.